If I had to start over today, if you stripped away my contacts at Apple and Google, took away my portfolio, and I was back to being a broke film industry worker with zero coding skills, this is exactly how I would get hired as an AI engineer in under 6 months. I've done it before, transitioning from 3D animation to building prediction models for the stock market in just 16 weeks. And I'm going to show you how to do the same without a computer science degree. If I had to start over today, the main thing I would do first is actually build skills that actually deliver on a real life solution as opposed to go and get straight degrees. Now, I know like 10 years ago when AI and ML machine learning was the main language and deep learning was like the buzzword that's going on, people were going all over the place and getting their credentials, and you can even go to university. I would say skip the university and even skip masters, because all these models are built now. They're known. What people want to know is how can you actually implement them, get it to work, right? People want confidence over just credentials. Because in the past, people would go get like a Google Cloud credential or an IBM credentials, so they know how to use that, or AWS. And don't get me wrong, those are important to know. But what happened was that people put that on their resume, and people are like, oh, you know how to use Google Cloud or AWS or Azure or something like that, so let's hire them. But the thing is, they didn't know how to actually build a pipeline. They show you how to use the platform, but you still have to go and work with a company, work with the real data, be able to curate the data, get the data, organize it, scrub it, clean it, and then actually apply a model, know what model will work. And once you know that, then you can put it on the cloud to basically build it out and actually use a string and then bring it back. You have to know how to use a pipeline. You have to know the domain to actually solve it, right? So in my case, I would say you start off with the basics, learn like the Python basics, and before you start using AI, because AI, you're going to be using this. The main thing is you want to get a pipeline and how to get from start to finish, right? From the main idea of that, right? Learning the basics of building this structure out, and even using the foundation, the basics, you get the main foundation, the baseline of getting it to work. And then once you have your input and you look at your output, you're like, is it getting the results I want? If not, what parts of the system is not working? And then you go in and use AI to enhance the parts that your traditional foundational stuff doesn't work, right? I'll give you an example. How I actually learned the basics of Python. I didn't actually go out and say, hey, let me just learn Python. In fact, I never really took any formal class. It was more in my industry. I used to work in visual effects and like 3D animation and AAA games or feature animation, things like that. And I was doing the same repetitive 3D pipeline tasks, which in a lot of companies, you have to deal with files. You have to move the data. You have to rename them, make sure they're in the right place where they live so they're found. So you come in on Monday, you just spend hours doing that. And then on Tuesday, you come in and do the same type of thing. And on Wednesday, same thing, and keep going forever, right? And people do that. So, but you're doing the same thing. So imagine being lazy, basically, I could say in a sense, is that like, well, I'm doing the same thing over and over. I just did this yesterday. What if I wrote a code that did this for me? So then I thought, okay, what would the code have to do for it to be useful? Okay, well, it has to, let's say step 1, find all the files, right? And then, okay, once I find the files, then what? Then I have to go in and then like rename them. Okay, and then like step 3, move files, right? And then let's say step 4, and then like mark is done, so like it's done like that, right? So once you know that, then I'm like, okay, well, I know the steps, I know what the start point is, and I know what the end point is supposed to be. So how do I do the stuff in between? So I would say, okay, step 1, find the files. Let me go and look up how in Python I would find the files given my folder structure. It might take me hours, it might take me days, especially if you don't know the language. You try to figure out how it works. And this is what helps you not going down a rabbit hole, because you have a very specific goal. Once that's done, I'm like, okay, great. I did step 1. Let me go to the next one. Then I found all the files. How do I rename them? Okay, then you look it up, do the same process. Okay, how do I move it? And then at the end, how do I like mark them as done? Once you know all that, like, okay, I can get from a pipeline from end to end. This is what companies are looking for. Able to take your actual real world problems, find out what the constraints are, how do you solve each one of them. Now, the thing is, the basics in this case, a lot of problems are basic, just like taking files, renaming them, placing them, and that they hire people to do this manually. Now, you could do this, and this will solve a lot of the problems, which shows that you don't always have to use AI. That's like taking a sledgehammer to an ant in a lot of cases where this is enough. Even if you use AI, it's not going to do any better because this is sufficient, right? But there are cases where, okay, I build a baseline, but let's say the move the files, for example, maybe in the case of how it's built up in your system, that the files live on so many different databases and there's a large amount of it that it might take a long time. So there's a new paper out, there's a new model out that you could use AI to go in and find it, all the data or that you need to be able to move them, and all the different places on the different servers, the different places they live, emails or folders, different operating systems or whatever. The AI is able to figure all that out, gather them, and move it. So you're basically doing the same steps overall, but now you're using AI or more stronger solutions for each one. And that's basically what you're looking for, right? So with that being said, you want to learn the foundations first, because foundations is what we use and it can get you a baseline. In fact, a lot of the cases, it solves the problem, right? Before you start doing the AI stuff, like if you see that it's working, but it's not giving you the optimal results, like we need to optimize this part, let's say to move the files, then you start looking into AI to optimize that part. You don't go around, at least I don't suggest you go around looking for AI like a problem looking for a solution, like a hammer looking for a nail, where you try to apply AI to everything. You're basically trying to solve the problem, get something working with the foundations first, and if it works, great, move on. If not, okay, how do we prove the parts? So here's the unfair advantage in AI. If I was starting from scratch, didn't know anything, because right now everyone's flooding it. They have AI for everything. It's hard to, you want to be the signal from the noise. You want to cut through all that and stick out from the crowd, right? First thing I would do is actually focus on Python, right? Now, why Python? Yes, you could actually use AI or build models from any language, but right now Python is the de facto. All the frameworks are built on it. So to avoid the overhead of, okay, well, reading a paper or using a framework or code or a model that's already built, that's built on Python, but now I have to translate it to another language just because I want to use that language, I would avoid any friction at the beginning. Of course, when you start working somewhere and they use a specific framework and language, you could transfer over your stuff then, but don't make it harder for yourself. The de facto right now, and that works in every case pretty much, is learning Python specifically. Instead of, don't go down a rabbit hole of, okay, I have to do like 100 days of Python or something like that. Those are useful, but just like if you want to learn to be a hockey player, you have to know how to skate first, right? But you don't have to learn skating to be a figure skater and learn every single thing. You need to know enough so you can play hockey and move on from that. So you want to know enough Python to know the coding basics, but mainly so you could use the main libraries from that's used in data science, that's used for AI and machine learning and deep learning. NumPy, which is basically a numerical Python, which is basically used for computation for heavy math part. So Python is a general language, so it's slower when you start doing like linear algebra or a lot of data to process to use math. NumPy solves that problem, and you don't have to go to C++. In fact, it's built on C++, but it's in Python, so it's fast, right? And the other thing is Pandas. So think of it as taking Microsoft Excel sheets or Google Sheets, basically spreadsheets, putting them into your code and processing them. That's what, and Pandas is even built on NumPy, but it's specifically designed for things like that, right? The next thing you learn enough to do that. The next thing I would learn is actually data cleaning. This is actually the real work. This is really where the value is, and this is where it falls apart, that PhD people, researchers and whatnot, they don't necessarily specialize in that. Yes, they know how to do that, but the thing is, they're usually dealing with curated data for their data sets, for their research. They hire people and they, like Mechanical Turk or something like that, to go and get the data for them, and you give them a template of how it's supposed to be prepared, and they can work with it. So they can take that and do very minimal manipulation of the data, and they can put it in their model and it works. The real world doesn't work like that. A company usually wants to hire you because they have decades of data, and this day and age is actually not the models or the algorithms that's worth its salt or worth value to the company. It's their data, their specific data. That's where the value is, right? Now, the issue is that they have decades of this data. And you can imagine how you collected data 20 years ago is not necessarily the same now. A lot of the data might actually be on paper. And they have storage rooms. And I can tell you for a fact I've done that, where you have to go in and organize storage rooms of things that are there for decades. And it's still useful data. But how do you organize it? How do you actually use it? You might have to go in, get that digitized, right? And then back then, the formula they use, I'll use the date, for example. That's not standardized. It might be day, month, year. It might be month, day, year. Maybe on the paper. At some points, they put the date on the top left, sometimes on the bottom right, sometimes in the middle. So you have to be able to clean that data, digitize it, conform it, meaning that, okay, we're going to decide it's always going to be day, month, year, and it's always going to be numbers, right? What do we do with missing data? Do we skip it completely? Do we interpret if it's around on these papers in this box? We could assume it's between this time. That's where the real work is. And that's why, like 10 years ago, when AI companies were like, okay, we can work with real companies and improve their processes with AI, they couldn't because they had no process of how to clean their data and make it work and know how to use CSV, like comma separated values, which is basically a text version, an ASCII version or something like that of a spreadsheet, of an Excel sheet or Google Sheets or spreadsheet, right? Now, I would also, when you start off, I wouldn't go into deep learning yet, meaning like the really complicated neural networks. I'll start off with scikit-learn, which is basically, it is a Python module. So you have Python installed, you could just bring this, you start using the library for it. It does actually machine learning, like with basic neural networks and classic models, like talking like linear regressions or random forest, k-means, things like that, clustering, like all that stuff. All those things you learn in statistics that a lot of classical models, when you're using statistical analysis, they actually, I'll tell you a secret, 90% of the time they work. They still work. So instead of you implementing them and learning textbooks or getting a math degree or a statistics degree or linear algebra, calculus or whatever degree, all this stuff, you could just go in, bring scikit-learn, just take 1 or 2 lines of code and applies the model to your data that you've cleaned on it. And 90% of the time, that actually gives you a good enough result for the business need. You don't have to go into deep learning, because you hear that all the time, because that's the deep learning or AI models or AI engineering, all those stuff are the buzzwords. But most companies are not deep learning or deep tech, deep AI companies. They're just regular businesses that have insight where the data and classical stuff work. Use those stuff. Use it if it works, right? Yes, it's boring, algorithms, but they literally run the economy. Go speak to any data scientist. They do the same type of thing, regression, random forest. And the thing is, even if that you need a more complicated model, you would still start off with these because they're already pre-made out of the box. It will give you an answer. The only thing is, if it's not good enough, the results that you get is just not going to be good quality. That's when you assess it. You're like, okay, we tried all of these classic models that work specifically for this type of data set that makes sense, and it's not giving us good results. How do we start using more advanced models? That's when you start going into deep learning, using PyTorch, looking at the state-of-the-art AI foundations. That's where you start looking at it. But you always try to find the easiest solution first, right? And this is, again, your unfair advantage. When you want to learn how to do from start to finish, right? With the start part is get the messy data from the companies, process it, right? And the processing part could be, again, start off with classic models with scikit-learn, just put them in right there, and then see the result at the finish. And again, like I said, 90% of the time, these boring algorithms actually work. A lot of things, linear regression, it's all you need. Just take the Excel sheet, put in pandas, and then apply like a scikit-learn classic model and use linear regression, and it works. And you solve the problem. Nobody knows what's happening under the hood, so they don't know that you're using the latest state-of-the-art AI. They just know that you applied it and you're solving the problem, right? That is one of the unfair advantage, knowing that process. The other unfair advantage is if your domain expertise. So if you are actually looking for a job and I would say look into a domain you actually know, because you know what the pain points are, you know what success looks like, and you can speak the lingo and the jargon and understand it and translate that into models, AI models or classic models, and get a solution out of that. Even if a PhD comes in and they might know more math, have more credentials than you, if they don't know the domain, it might as well be speaking another language to them. So they have to go in, try to interpret that. And a lot of times they misinterpret because they'll get information from other people. They say like, okay, well, this is what we need, not fully understanding the actual process because they don't know that domain or haven't worked with it for years or decades with it, and miss a lot of the nuances. So they don't know what success is supposed to look like. They don't know the pain points. To them, it's just numbers. And they're like, okay, well, our metric says that's good, so it must be good. And anyone who actually works with it, you're like, this is obviously bad. You're looking at the wrong things, right? So that is literally an unfair advantage for that, right? When I started using AI, I was looking on domains that was in my field. I started actually my first job was really like predicting the stock market, but it was very similar, and also around the time as well using 3D solutions, because I knew those pipelines. I worked in visual effects. I worked with large data, had to crunch them and put it out. Working in the stock market was very similar. Yeah, I had to learn some other things, which I learned along the way. So when I applied it, I was able to actually solve that problem. I didn't go in and start saying, okay, I learned AI, I'm going to go straight into healthcare. And I didn't know anything about that, right? I would have to learn the domain first and then start making portfolios. So I bring those gaps together. So the other part that I would suggest when you actually start looking for jobs, here's the biggest secret. Most companies, they know that AI is a buzzword and they're like, okay, they think it's magic. We have this problem, let's use AI to solve it. But they don't know how to describe what the actual problem is or what the role is. So they look at other companies and look at like certain terms like, okay, we might need a data analyst or a junior Python developer. And it's just broad like that. But that because they don't know how to describe what's the solution they need, right? So I would say look for familiar industries that you're expertise in, that you know what the problems are, that you're a domain expert, you know what the problems are, you know what the solutions are, you know the nuances of, right? And you know how your AI skills can actually benefit in that. And look up anything that's related to like roles that are data analysts or junior Python or whatnot, and see what they're actually trying to solve. And then reach out to them and then say like, hey, I know this is what you're actually trying to solve. And then you actually pitch how you would actually solve it. Because when they look at you, you're like, I know this domain, and you have like a track record in that. So like, okay, well, this is someone who knows what we're talking about, and you know AI, we could actually listen to them. And then usually when you have that conversation, they actually describe what they want, and the role itself, it's like an entry to get in there. But then you actually find out what the real solution is, and then you could pitch, this is how I actually would solve it, right? And then the actual role itself doesn't actually matter in that case, because they're actually trying to find a solution, and they just didn't know how to articulate that. And you could be that gap to be able to like, this is what you're actually looking for, and this is how I could solve it, which automatically shoots you up to the top of the list of candidates. Let's talk about how this actually helps your career and how do you break the 200K and plus mark in salary. So yes, AI, if you're a researcher, they get paid really well for that. But also if you're a researcher as well, most likely you have to have a master's or PhD and go to prestigious schools and have credentials and publish papers and whatnot. But the thing is, if you're an actual like engineer, from someone who not just makes theory but actually deploy it, know how to actually take the data, know enough of PyTorch to actually deploy it, build Dockers that are actually reusable so you could deploy it on local computers on-prem or like on premises on other computers, how to take that and scale it up on AWS or Google Cloud or Azure or any other, right? And scale users and actually implement this. Researchers and PhD people don't specialize on the engineering part of this and actually make it usable, right? deployers can earn more than pretty much the builders because they actually make it work at scale, which is the main thing they need, right? So I would suggest, when on top of learning how to use the AI, how solving the problems and all that, become a full stack AI engineer, right? Learn the actual software engineering side of things and DevOps side of things. Learn Git, like basically source control. How do you write code that you could work in a team and everyone updates the same code base? You want to learn how to do tests, like test-driven development. This is a big thing that is huge, actually. And especially when I teach people how to code, I know people want to learn coding and get to the results right away. I highly suggest, and I can tell you this from working on like Apple Vision Pro, working with professionals at that level, working on self-driving cars, dealing with a distributed team and a code base where multiple people are working on it at the same time. You want to make test suites using TDD, test-driven development, where basically you make tests to make sure that the code works and test it before you actually deploy it. So you do tests like, you could do something as simple like I make a function that adds the first number to a second number, it gives a result. So your test would be, if I give the function 1 plus 1, it should equal 2. Does it actually equal 2? So if it says yes, it's 2, then you give it an assertion and like, yes, that's good. So you know this function works, so move on to it. So if you're doing it and then you make a code change and something breaks, that's called regression, right? Then it goes back and you say, I make a code change in the database, and then I go back and do this test. 1 plus 1 is now equal 4. You know that's wrong because it's supposed to be equal 2. So we know right away this function broke. Let's go back and fix it. This approach of how to design is super helpful because this prevents technical debt, or we build things to get it out the door with like sticks and bubble gum and scotch and like duct tape to get it out the door because it works. But then you keep building on things that are not well designed, and at the end, you don't want to refactor. Refactor means go back and change the code to be more efficient and work better, because it's now spaghetti code and hard to work with. And almost every company I know works in that way, and that's where their cost comes from, right? If you're able to do that and do it in a more efficient way, you are a lifesaver to them and you're worth more. And again, you become important. Important people get what they want and they get a lot more money, and you can do what you want. You have a lot more leverage with your time as long as you're delivering and you have that skill set. And then APIs, these are application programming interfaces. How, once you have a code base or you're working with a code base that exists, how you actually interface it to work with it. Because they're like, okay, we make this solution, maybe something that generates images. Here's the API so you could use it in your code. So how do you take that and build it out? That's why becoming a full stack engineer is very helpful, because it's kind of like Python. It's universal. Every system, every like code, web development is the most universal code, because you could make web apps, or whether you're on Linux or on Mac or on Windows or on your mobile device, everybody has a web browser. And if you make code that works in that, it works on all those devices, as opposed to making native code, native applications. Then you would have to learn, if I'm doing it on Android, I have to learn Kotlin. If you're going to do it on like Apple, you might have to learn Objective-C, or there are other languages that they're using. They change it up all the time. And then if you're going to be on Windows, or there's a different things, the .NET suites, or you could use Qt, or like Qt or Qt, or you could use PyQt, or you could use Python as the main thing. There's a lot of different ways to do it now. We have to manage all that stuff. Learning full stack is the most universal. In fact, even if you could go onto another platform, you could prove it out on this, and it's also the most scalable. Even if you have like native platforms, you want to scale that up. This makes you universally prepared for pretty much any industry, right? And this is why you want to shift to the engineer part, because actually making workable code, and like I mentioned before, even if you learn PyTorch, most of the time, you don't need the heavy duty PyTorch or the latest AI model. You could use just like scikit-learn or use the basic linear regression, and it works most of the time. But this learning how to scale it and build it out is still going to be the most important part, right? So a researcher won't be needed if 90% of the time just basic algorithms that come out of the box work, right? You really want to have a production code mindset. If what all you want to do is have a solution to the problem that the business had. Not look for the most complicated or a hammer looking for a nail, looking like, oh, there's this new paper that's out, the new AI model, I must use it. No, what works, I could use just the basic things and I get out today and it works, we can move on, right? The other thing on how to actually increase your salary, and this has been generally true, just not in this industry, but like pretty much forever, is that you want to reset your value by like typically projects last like a year or two, like a year and a half, 2 years, maybe 3. That's a while. So you want to basically, once you finish your project, this is why you want to stay up to date. You want to start shopping around if basically your skill sets to other people. And I wouldn't say shopping around, it's more be open to it, because what usually happens is that when you update your resume and they see, oh, you're working at a real company, you're solving real problems, and you've been there for a while, now you become attractive to other companies and they start reaching out to you, right? And they just come out of the blue and say like, hey, I know you're not looking for a job right now, but I see that you work at this company and we might have something that's interested. Like, reach out to me if there's, to see if you're interested in that. And even if there's not a good fit, let's stay in contact and see maybe something in a role, or when you're ready to move, all of a sudden you're attractive to other people, right? And this is when you go to the other place to make it an incentive, they would offer you a much higher salary, especially if you're proving that you're worth at companies. It's like, hey, I'm working at this company, I'm delivering this type of value, these are the type of solution, and you're still there after a while. They're like, okay, this person actually knows what they're doing. We need them. What we need to do? And they'll usually increase the salary to bring you aboard, or have a signing bonus or things like that, right? Again, your portfolio proves real ROI. Now, yes, the recruiters do come with you. Now, again, I would say you be open to it, because the other option is, yes, you can stay at the company, but a lot of times 2 things either happen. Like, either A, but like, they spend a lot of energy trying to get you, but once you're there, they kind of like forget about you. Like, okay, well, you're good, let's find other people. When companies already have you, they kind of get complacent, and they think, okay, you here, you have a stable job, right? You're not really going to go anywhere, so they don't have much incentive to actually pay you more, or even when you have a promotion or anything like that, they usually play less, and you have a lot more restriction, or a lot more friction when if you ask for a raise and whatnot. They're trying to assess, okay, well, what's your likelihood of leaving? Okay, we're kind of like lowball you, right? But when you have other companies after you, and they feel like, okay, you're valuable, but you're gonna go somewhere else, right? Then and they know that, then all of a sudden they're willing to match or pay you higher for that. It's part of the game of it. So you want to know your worth, is that you bring in, you bring in the skill sets. It's hard to get into it, but once you have it, you want to leverage that to go to other companies. Now, one thing I would like to say about that is that that's not to say is that make sure you're delivering for those companies, because there are people who come in and just start like job hopping before they finish a project, or they go on. If you keep doing that, people will notice like, okay, well, you're just here and you never actually deliver anything, right? So you have to be able to deliver, but also know your worth, to know that once you actually deliver something, you are proving your value and your worth, and it's a valuable skill. Other companies want it, so you could keep your options open, or stay at the company, but just let them be aware of your worth. I know all this sounds overwhelming, at first at least. You want to be able to turn chaos into a plan, because if you don't have a plan, you're pretty much just going to go all over the place and not focus on anything at all, right? And it's actually a good thing that it's overwhelming at first, but you know what to focus on, having a structured, proven roadmap, and the fact that it is overwhelming at first, again, to people, because that is actually the deterrent. In fact, when you go into universities, did you know that a lot of the prestigious university is actually designed that you want the 60% of the people to drop out the first year, because they want to weed out the people who cannot hack it, and it gets a little easier a lot later on. One is to show people who are actually able to go through the program, who could persevere. If they could persevere that, they could actually persevere in the real world. And also too, it shows a certain quality of people. The fact that it's overwhelming at first and you could actually stick through it, that alone, for you trying and sticking through it, 95% of the people you're going to be ahead of people right that of who's actually trying to get into this, right? Instead of I know ChatGPT and they apply to jobs, right? And the exact stack that I showed you, because the first thing, okay, I'm going to learn AI, I'm going to learn Python. Okay, but what do you need to know specifically to be used in a real AI engineering company solution-oriented setting, right? You want to be able to frame your portfolio that's actually useful to companies, right? And starting from scratch, you want to show your experience basically without the years. And in terms of experience, you're like, listen, these are the portfolios. This is how I solve a problem from beginning to end, how I'm able to take it, and here's the results at the end of it, right? And once you get your job, I also mentioned the career progressions of it, is that now you're going to be attractive to other companies. So at first, when you are nobody and you're actually applying to companies, you're going to be ghosted. It's kind of like in real life when you're not known or anything like that. You try to approach people, they're gonna ghost you. But all of a sudden, if once you are actually achieving things, you start noticing that you don't actually have to go out and approach people as much. You're gonna start attracting people, and all of a sudden they're responsive when they want you, and they see you could deliver on things. They're gonna start wanting you and come after you, right? And how that actually works is, of course, there's the concept of a sizzle and the steak, right? The sizzle is kind of like what attracts people, and that's where you see all the hype, all the trailers. When we look at sports, for example, you could use, let's say, the NBA. They'll show the highlights because that's what get people excited. But when you actually look at the entire game, most of it is the fundamentals, the utility over it. All the great people, they show the highlights, they show the great things that they do, but most of the 48 minutes, they're basically doing the functional utility things. That's what wins the games. Like, they might have scored 80 points. Maybe that's not pretty high, though it is possible. But let's say they scored like 30 points for the game, right? They might show highlights for like 3 or 4 of those points, but the other like 27 points that they had, was just doing the basic layups and whatnot, right? That's the same thing in real life. Mostly you want to be able to do the fundamentals really well. That's why you want to know the structured proven roadmap, because like I mentioned before, knowing the math that works most of the time, like using, let's say, scikit-learn and just using linear regression, works like 95% of the time, right? So you know the utility and that works. You don't necessarily, the hype is kind of like what attracts people. Utility and boring stuff, that's what actually gets the job done, right? So pretty much this is kind of like the clear hiring map of that. You work this out, you show your work actually has impact on a business value, and then once you actually get a job in that space, you start becoming more attractive to other people, and your worth starts growing if you basically showcase that in the right way.